Look up on a clear night, and the stars seem permanently pinned to the dark sky. But that stillness is an illusion. We are sitting on a rock, spinning through a galaxy defined by constant, active movement. This map details our cosmic neighborhood. The Milky Way is one piece within a cluster of galaxies known as the local group. Within this cluster, our dominant neighbor is the Andromeda Galaxy. It is the largest and most massive structure in our immediate vicinity. Mapping our position within this group changes our view of the night sky from a static photograph into a countdown. These stars are on a specific, observable path. The Milky Way and Andromeda are locked in a gravitational tug-of-war. The immense mass of these two stellar bodies pulls them across the void toward a shared central point. Comparing speeds, a commercial jet travels roughly a quarter kilometer per second, but our galaxies are closing the distance at 110 kilometers per second. Tracing this velocity forward provides a deadline. In 4 to 5 billion years, our outer edges will meet. This is a mathematical certainty. Based on their current mass and trajectory, a direct collision between our home galaxy and Andromeda is inevitable. When you hear the word collision, you likely picture a violent, destructive impact. But on a galactic scale, the physics of a crash follow a different set of rules. This scale illustrates the makeup of a galaxy. We focus on bright stars, but a galaxy is almost entirely empty volumetric space. To put this in perspective, if a single star were a golf ball, its nearest neighbor would be hundreds of miles away. Because the gaps between stars are so enormous, a galaxy behaves less like a solid object and more like a diffuse cloud of dust scattered across a wide canyon. This internal emptiness explains why two massive cosmic bodies can slam into one another without a single physical object ever touching. At the exact moment the outer spiral arms of the Milky Way and Andromeda overlap, you won't see explosions. Because galaxies are mostly empty space, the probability of our sun, or any individual star, physically striking another star is virtually zero. The hundreds of billions of stars will simply slide past one another like two banks of fog passing in the wind. However, even without physical strikes, the enormous gravitational pull of each galaxy will yank its neighbor's stars out of their familiar orbits. Physical matter never touches. Instead, invisible gravitational fields clash, pulling the stars in new directions and twisting both galaxies out of their original shapes. After that initial ghostly pass-through, the combined gravity of the scattered stars acts like an elastic band, slowing the escape and pulling the two masses back toward a shared center. Over millions of years, the distinct spiral shapes we recognize today are shredded, warping and folding together into a single mass. This diagram contrasts our current flat disc-like shape with the final outcome, an elliptical galaxy. It is a rounded, unstructured oval of ancient stars. Astronomers have already named this future entity Milkomeda. If you were standing on a surviving planet within Milkomeda, the night sky would look entirely different. Instead of a narrow band of stars, the sky would be filled with a bright, uniform haze in every direction. On a cosmic scale, a galactic collision is not an apocalypse. It is a slow gravitational dance that reorganizes the local universe into a single unified structure.